Precision versus accuracy. In biostatistics, accuracy refers to how close a measurement is to the true value or accepted value, while precision refers to how close repeated measurements are to each other, regardless of whether they are close to the true value. In biostatistics, both accuracy and precision are important for reliable and meaningful data. Let's discuss them in details. Number 1. Accuracy. A measurement is considered accurate if it is close to the true or accepted value of the quantity being measured. It is the closeness of the measured values to the true values. For example, if you are measuring the weight of an object and the scale shows the actual weight, the measurement is accurate. Number 2. Precision. A measurement is considered precise if repeated measurements under the same conditions are close to each other, regardless of whether they are close to the true value. It is the consistency and repeatability of measurements close to each other. For example, if you take multiple measurements of the same object and they all read the same value, even if that value isn't the true weight, the measurement is precise. Here is a simple example to understand it. Think of it like a dartboard. Accuracy is how close the darts are to the bullseye, the true value. Precision is how close the darts are to each other. A sample can be precise, that means it is repeatable, but not accurate, meaning it is far from the true value. Or, a sample can be accurate, but not precise, meaning that the results vary widely. The ideal scenario is when a sample is both accurate and precise, meaning the sample estimate is close to the true population value, and the results are repeatable. If you are measuring the blood pressure of a patient, it's important that the measurement is both accurate, close to the true blood pressure, and precise, repeated measurements are close to each other. In summary, accuracy refers to how close a measurement is to the truth, while precision refers to how consistent the measurement is across repeated trials. Both are essential for obtaining reliable and meaningful data in biostatistics.